The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
So the last presentation today, we saved the best to last, is a presentation that was supposed to be given by the co-moderator of the session, which is Ralph Tullis, who sits on 347, to give us the contractor's point of view of lessons learned and some of the things to watch out for. Ralph unfortunately could not be with us today and asked another colleague from both ACI 347 and 237, Eric Peterson from Webcore Builders, to help him put the presentation together and deliver it. So Eric, you deserve a double upload for having stepped in late in the game a couple of weeks ago to fill in for him and for giving us a presentation. Thank you.
My name is Eric Peterson. I work with Webcore Builders out of San Francisco area. Currently I'm working on a project in Guam, so I'm still recovering from the time change here. And as, I don't know, can you all hear me pretty well? Yeah, this is fine, thanks. And as Kamal stated, this is not my presentation. I've adapted it a little bit, but this is a presentation of Ralph Tullis, and I'll go through it as well as I can. I have, in my experience, one fairly large project that used about 8,000 cubic yards of SDC concrete for the Cathedral of Light in Oakland, California. This presentation will not discuss the design of SDC mixes. That's been covered in other areas. It's going to focus on the behavior of SDC in the formwork. It's going to discuss placement pressures, and we'll also discuss formwork design with regard to the placement pressures and other formwork details that are important to consider that are unique to using SDC. And it's primarily, of course, focused upon the vertical application of SDC. What is self-consolidating concrete? First of all, this is a photograph from, a lot of the photographs here are from the Cathedral of Christ's Light, and that's our placing crew right there. And in fact, we're placing concrete right then and there. He's got a steel tremie that's inserted into the wall, and they're just bumping away, and that concrete's doing what it's supposed to do. It's flowing into the cathedral walls. SCC concrete is a very fluid concrete mix, flows into place of the form with no additional assistance, or we should say no mechanical energy being applied. Mixed with paste properties such that the aggregate neither sinks or floats to the top. That's, I guess, something we would call dynamic and static stability. And develops an internal molecular structure, which I believe Ralph is trying to refer to the thixotropy aspect of SEC that limits the maximum lateral pressure seen by the formwork. The fact is that thixotropy is a reversible process, and he's making the point here that if the formwork was to experience vibration, that it could return to a fluid state. Desirable properties of SCC from a formwork perspective: rapid internal structural buildup, and I'm going to say that's a double-edged sword, because when you have rapid or very high thixotropic mix, you have to be very concerned about interlayer bond, because when you're placing a high element, you need to be able to get back to that element before thixotropy takes effect, and you have difficulty achieving bond between layers. So while thixotropy is our friend with regard to formwork pressure, it is also something that you have to be planning for with regard to the size of the placements that you're making. Robustness is by definition how things can vary from day to day, and the consistency and predictability of what you're going to be able to achieve with the particular concrete. That's a definition of it, but in SCC that's very important. Remains consistent from truck to truck, point of placement. A lot more quality control involved in SCC. A lot more attention needs to be paid to it than conventional concrete, at least at the outset. And is not adversely affected by a placement method, or and is predictably consistent from the point of placement. SCC placement pressures. Okay, this is some formwork again at the Cathedral of Christ the Light. That was all the walls were circular in plan, and they had a inclined slope of about 10 degrees, so they were conical surfaces. And the placements that we had on that project were fairly extensive, and we were after a very high quality as cast finish. And one of the things that we did with this mix is we put a hydration stabilizer in it so that there was absolutely no chance of having an issue with interlayer bond. So we were designed for full hydrostatic pressure on this project. That's so here studies are ongoing. Some researchers feel they have enough data to predict pressure. Both the presentations prior to mine discussed the various models that are being used right now. I know that ACI is considering the DIN 18218 and Kamal and Aman's model, as well as the Gardner model. I've looked at all of these, and what I look for in them as a builder is, if I'm going to design my own formwork, how easy is this to use? What do I need to know about the mix in order to be able to use one of these expressions? And I find actually probably Kamal's and Gardner's expressions probably the easiest to get along with. Ideal mixes can result in placement pressures less than full liquid head. And in fact, everything I've read is that you never achieve full liquid head. Very, very seldom, but 90% is not uncommon. But it's, I've seen some studies where phenomenal rates of placement were made and still full liquid head was not realized. Can be dependent on SCC producer and readily available constituent ingredients to be used. And sensitive variations of ingredients, moisture, aggregate variations, and that is extremely important. Understanding what to control during the time that the SCC is being provided to the project, whether or not it's going to be the high range or the VMA or the moisture, whatever needs to be adjusted to maintain the characteristics of the SCC is something that has to be controlled by the ready mix facility. SCC placement pressure. Within an unknown mix behavior, the design placement pressure should be full liquid head, and as was stated earlier, that's still the recommendation of ACI 347, although we are considering these models. So from a contractor's point of view, what would be done now is that you would have to characterize the mix, maybe use one or more of the models that are out there right now, try to understand the concrete that you're using, and make a determination yourself as to whether or not you need to design for full hydrostatic pressure. Can be indirectly monitored on site with simple instrumentation, desirable with an unknown mix. These are some of the walls from the inside formwork challenges. Too often formwork decisions must be made before the properties of the SCC is really known. That's very true. In a project, you're mobilizing to start working on the job, you're getting mixed designs submitted, you may even still be buying out the concrete at the time that you're starting the work, and the formwork for something that's complex and that needs to get going is probably being designed before you know a whole lot about the concrete or have used it very much. So you have to make some assumptions. In the case of this cathedral project, we had below this level, below that floor level, is a system of isolation, base isolators, and then about a 3.5 foot interstitial space where those isolators resided, and below that was an entire mausoleum. And the mausoleum had a very similar wall structure, including some central walls to the cathedral above, and I utilized the SCC concrete that we planned to use on the cathedral in the mausoleum to get that familiarity with the mix. So that's just a strategy that you might use, is find places where you can use this mix before you're actually putting it to work. Knowing SCC behavior, the decision of proper formwork design pressure is but a guess. Without knowing the SCC characteristics, you'd be guessing. And if you're going to guess, then you go with the hydrostatic. Last-minute formwork design changes due to a slow to stiffen SCC mix can be costly. Formwork challenges. If SCC is slow to develop its internal structure, placement rates must be reduced to keep below the design placement pressure. This can impact supply train, reducing the frequency of delivery, possibly causing concrete to sit in the truck too long. I think what we would say about this is, again, you characterize the mix, you understand what your forms are capable of, and this would not only be based on analysis, but this would be based on watching the performance of the formwork, where you're getting deflection, where you're getting movement. If joints are opening up, you're going to learn by experience what those forms can withstand and whether or not they need to be strengthened, and you'll adjust your pouring rate based on what you learn for using the mix over a period of time. And then adjust your pouring rate, the placement size, what you might, how fast you can go vertically in a form system. Placement rates for large volume placements can be easier to adjust. Slowdowns of small placements of 1 or 2 loads can be a problem. What I do let's just say you're placing something that doesn't have a large volume, but you can't place it very rapidly. You just don't get full trucks. I mean, that's all there is to it. And you will know that going into a job that you're going to have placements like that, and you will discuss that. I usually discuss that with the concrete supplier before we sign on the dotted line, so that we're not seeing a premium for a cost for a charge like that. That's SCC. Design placement pressure has an effect on economics of the form system. That's obvious. Modular forms from rental stock have standard rated safe placement pressures, and that's an important point to know, because there's a lot of use of various types of modular form systems, and they're all rated for pressures that I would consider to be fairly low when you're dealing with SCC. I mean, 1,200 pounds is nothing to SCC. Pressure ratings vary from 1,000 pounds to 1,500 pounds. I know of some that are up in the 2,000 to 2,200 pound range. Forms with higher safe placement pressures are available now. They're always readily available. Formwork considerations. Project considerations can affect formwork. Required concrete finish will also influence the form system. Unexposed concrete usually permits use of any or almost any form system. And architectural concrete, particularly when there are specified form tie and panel joint spacings, will always require custom forms. Now, custom forms you can obviously design to withstand any full-size hydrostatic head. The other thing I wanted to point out that I'm not sure if people realize is that why is such rapid vertical placement possible with SCC? And the rapid vertical placement that you can achieve with SCC is basically when you place conventional concrete, you have to place it in lifts. You have to mechanically vibrate these lifts, and that takes time. And hauling ass, in something that's, excuse the expression there, in something that you're placing vertically, you'd be doing good to do like 14 feet an hour if you were just really, really going. SCC can wipe this out. You can place walls literally as fast as you want to, as long as you have the supply. So SCC enables a contractor to do something that they couldn't do even if they wanted to do it with conventional concrete. Something I wanted to point out in this image before moving on is, because SCC is so self-leveling and flows for such great distances, when you have changes in elevation like this, so you can see that we placed this wall element all at once, and we had a drop where there's going to be a beam that comes in to this wall, and formwork for SCC requires us to cap this entire elevation change. There is no way, traditionally with conventional concrete, we would put a bulkhead at the step and then maybe a cap that might come out about 4 feet or so that we can prevent the boil up that might happen on the other side of that step. SCC, if you have a step like that, 30 feet down, it'll start coming on the other side of the cap. So pretty much so when you have a step in a condition in a wall like this, you need to cap the top. The ideal formwork for SCC would be completely watertight, and it needs to be very tight. And one of the things that I do in a situation like this is we inspect the formwork prior to placement to see if there's going to be potential leaks. And I also keep like a leak kit that we have around that's got anything and everything that we would need to stop a leak right in its tracks so that we can continue placement without interruption. So the guys that are on floor watch, they'd have things like oakum, packing, foam, backer rod, just about anything that if you get a leak that you're able to get in there, put something behind it and stop it from progressing. Because otherwise it just keeps coming out. Believe me, it does. Okay, modular forms can have a number of slots and tie holes that you need to make sure that you're not going to lose pace through. Larger unused tie holes will always leak and can adversely affect concrete nearby. Euro-style modular form tie systems can be equipped with cones that will seal well. That's a very common tie system that's used for a lot of work. In fact, it was used for this job here. We used internal PVC sleeves with the cones on the outside. Those make a nice seal against the form. Formwork specifics, modular forms, panel-to-panel joints can leak pace depending on the style of form. I'll talk about that just, I think, in the next slide or so. Earlier style panels, modular forms, steel ply, etc., have a number of tie and hardware slots that will leak paste. Like some of the older Simon's forms and things like that, you'd have a really difficult time sealing properly for SCC concrete. Installing gaskets between these form panels is possible, but labor intensive. This was a system that I actually used in the cathedral. We had double-faced plywood so that we back-screwed the face panel so you didn't have any fasteners on the architectural side on the face sheet of the form. But I also, this was my own idea, I routed a slot in the edge of the face panels to receive what I used was tempered masonite, 1/8 by 3/4. And so when we would bring two large gangs together, we would get the gangs together and I would have that masonite stuffed into one of the panels and then move the other panel into it. And what that did was it assured the flushness, which was extremely important on an architectural building, and it also provides that backing so that even if there was a small gap in that form, it would come into that key and that would stop the grout loss. And the main thing in an architectural wall is you want to stop the grout loss because that's where you see the bleed marks on the surface of the concrete. So if that joint leaked a little bit, it's okay. It would hit that masonite and that would stop the progression of grout loss that would cause something to look unsightly on the form face. Formwork specifics, panels, Euro-style modular forms. We've already covered this, haven't we? Am I going backwards here? Okay, most little tie holes are used. All right, so this is I used this picture because you can see the double plywood. The interior, the exposed face had a system of horizontal reveals that covered the seams, and that was back screwed. And there was two reasons on this project for using double plywood. One was, of course, to back screw so that we don't see the fasteners, and the second was the strength that we needed for full hydrostatic pressure. Architectural concrete with specific joint and tie patterns almost always require job-built panels. This is the two layers that we just talked about, and joints between the face and the structural layers should be offset. So the point here is that if you're going to use two layers, you don't stack the layers so that the seams are in the same locations. Interior form-facing panel joints on gang forms should be caulked with a high-grade silicone caulk. This project had no chamfer in the corners. Everything was sharp corners. But even still, all of the corners, we caulked them with it was an acrylic latex it was a siliconized latex that we used, and we would get it into the 90-degree corners with a very, very tight radius, and that gave us a sharp-looking corner without having any grout loss at the corners. And I guess here I'm mostly talking about forms that were designed for architectural work, but some means of, I don't care if it's architectural or not architectural, you need to consider much smaller leakage in SCC formwork than you would consider in conventional formwork. So you need to have some means of sealing your joints. Form ties must be a type. We've already covered that. Form should be set against or on sills, kickers that have been sealed to the underlying footing or slab. Seals, foam tape, caulk should be applied. Okay, this is again talking about how to seal the formwork. I've got SCC will mirror every imperfection in the form face. Do not permit nails to be used or located for locating like reinforcing bars. The holes will be reflected in the concrete when the panel is used the next time. Anything that's done to the form will be imprinted and seen in the surface of the next use. Consider the attachment methods to be used for any kind of embeds. Ideally, this should be fastened from the backside of the form. So this is the wrong way to stop a leak or to prevent a leak. This was actually done prior to the casting of the concrete. You can see they sprayed foam, spray foam at the bottom and then capped it with a small piece of plywood and nailed that to the sill plate down below. That's the wrong side of the form to stop leaking from, because that seal will actually see pressure. That's going to open up that seal, and then you're going to have concrete coming out. This is the method that I prefer. You seal your downboard. That's got a gasket underneath it, and then that downboard can take care of any unevenness that you might have at the base of the form for elevation, and then your form itself would have the vertical elements up high enough that only the plywood face sheet would come down and lap the downboard, and then that seal is effective. You won't lose that kind of a seal. This is just another view of sealing the forms. Release agent is something that you have to consider with no matter what kind of concrete formwork you're doing. Whether it's conventional or non-conventional, you have to be using the correct release agent in the correct amount, and most people tend to overuse the release agents. Forms must be carefully separated from the concrete to avoid chips and spalls. So again, in this case, I was dealing with sharp corners, a lot of reveals, a lot of incorporated features, speaker niches, and other features like that. So it's important to wait until the concrete has enough maturity and hardness before you strip the form so that you don't damage it. One of the things that we could do with SCC on this project was these wall openings. The height of the concrete underneath these wall openings was only about maybe say 250 millimeters on the high side and maybe 800 millimeters on the low side. 200 millimeters on the low side, 250 on the high side, and we would pour the concrete from one side. It would flow. We'd see it start rising in the kind of the mullion between the two spaces, and then we'd bring the tremie over to that side and keep pushing this concrete, and we could get that concrete to flow completely underneath these long openings without any consolidation effort. SCC can be placed around wall blockouts, even large wide openings. Proper concrete placement around blockouts can result in complete filling of the form underneath the blockout. Again, though, you don't want to trap the concrete. It's very important in situations like this that you work from one side, allow the flow to come to where you know that you've actually already raised, that you have a higher level of concrete than the bottom of the sill on the opposite side of the blockout. And then you can move down and do the same thing and do the same thing so that you don't trap air underneath the long blockouts. Placement openings in the bottom of the form can be eliminated. Standard cone, we've talked about the ceiling. Formwork design considerations. Actual placement pressure is the greatest known when using SCC. Greatest unknown ASCI 237-347 have been following much of the research done in this area. Many studies have attempted to fit equations to the data. I think that this gap is closing, as Peter and Kamal have shown here. I'm hoping that we're going to be able to use something that's consistently used in the near future. You really do need to work with the, especially when we did this project, the supplier that we used had never done it, ever. And we went through considerable effort to develop this mix and get it to work the way it was supposed to work. We got some consultants from the industry that helped the batch plant make an effective SCC mix. And as I said before, SCC, you can get a lot of benefits using SCC, but the quality control has to be a little bit more rigorous than it is with conventional concrete. I can't really attest much to form failures with SCC. I think that when you design a full liquid head, it's pretty hard to have failures. You just need to make sure that you put your system together where it's supposed to be assembled. But I think that you would have the kind of failures that you can expect with overloading a form for its lateral capacity. Bulkheads, fillers, pilasters require more attention to detail because of the propensity to leak and also the attachments. You can see the kind of structure that we had inside there for forming that niche. Okay, and consider instrumenting some ties to document actual placement pressure, and this has been talked about already here. I know that Ellis Don does a lot of instrumentation. I know that Kamal's done a lot of instrumentation, and that in fact the round-robin testing in Stockholm did a lot of testing. This is a device that's made by Geotech that's a load sensor designed for soil testing, but that works very well for doing this kind of testing if you want to characterize your mix by actual experience with it. There are other types of sensors out there. And I think the main thing here is if you're going to do a sizable SCC project, being able to understand the pressures that you will be experiencing in your formwork will allow you to design the formwork efficiently. Columns are filled with full liquid head, probably regardless of whether it's SCC or not, so you're always designing columns to full liquid head. Consider the following ready-mix truck. This is another project, and this was a highly flowable concrete that I used in these columns, but it was not SCC, but I injected from the bottom, and I injected from port to port to port to port all the way up. It was a 45-foot lift vertically, and the column was inclined at 20 degrees. And what I did was I sized the trucks so that I would inject from one port to the next with a single truck. And then I could control the time between trucks, which would limit the hydrostatic pressure building up in the column forms. So just basically what this is saying is plan your placements so that you know what you're doing to your formwork. Okay, and that's about it. Thank you for your attention.
Thank you very much.